Hello everyone and welcome. This is our 2.3 Google Slides intro to what we're going to be looking at this week. We're going to be looking at comparing linear, quadratic, and exponential functions. So these are three really big topic types of functions that we see in algebra. And we're just going to start at our basic understanding of how to identify if something is linear, quadratic, or exponential. And we're going to be identifying that from graphs, from equations, from tables, and from context. So on the first slide, you should be able to put your name and type it into that box. And when you're ready, push ahead to slide 2. So this is your own Google Slides. So whatever happens on this slide is going to be your notes that you can always come back to. So the first thing we're going to do is to just take a look at how these graphs look and look different. For example, a linear makes a straight line. So this linear function is going up from left to right, which is why this is linear increasing. So you're going to grab that red box and put it around increasing. If it was a decreasing function, it would just be going down from left to right like that. It can also be constant, which would be a flat horizontal line. That is when we have a slope of 0. Those are our three types of slopes for linear functions. In the middle, we have a quadratic. So a quadratic always looks like a U, and it's either opening up or opening down, like an upside down U. This is opening up. If it were opening in down, then that would have a negative in the equation in the front. Those are the two types of quadratics. They're either opening up or opening down. And then we have an exponential. From left to right, this is an exponential decay. Exponentials they grow slow and then they jump really quickly. They make this it's kind of like an L shape. This is the decay, and then the growth just goes, the other direction, starting low and then jumping up high. Like that. So those are our two types of exponential functions, either growth or decay. So once you have everything you need on this slide, feel free to push ahead to number 3. Okay, so with linear, a lot of the times we're thinking, is it increasing or decreasing? So remember, our linear functions make a straight line. So we look for the ones that have a straight line, and there's two here. There's this one and this one. So linear is just a straight line, and we always read it from left to right. So here's the left part of the graph and to the right. So left to right, this graph is going up. So this one is increasing. And this one, this blue line, is going down from left to right. It is decreasing. Beautiful. Quadratic makes our U-shaped graphs, and they're either concave up or concave down. So here's concave up, making a U, and here's an upside down U, concave down. And then for exponential, our growth looks like this, again from left to right. It starts off low and then jumps up, versus decay starts off high and then comes on down from left to right. So make sure you have those 6 categorized in their correct position, and when you're all set, you can push to slide 4. Just starting to notice the differences between each of these types of functions. So a linear function, a straight line, has an x with no exponent. So notice these x's that we have here have no exponent. It's just an x on its own. If the number in front of x is positive, then we're going to be increasing. So 5 and 1/2, both are positive numbers in front of x. That's our slope, and that's a positive slope, so it's going to be increasing. For the next one, it's a little tricky because the x is not alone yet. So we have 2x plus 3y equals 6. So what we're going to do here is we're going to subtract 2x because when we're in our form for linear functions, we want the y to be by itself. Notice these two equations have y equals. So that's what we're trying to get. 2x minus 2x cancels to 0, so we have a negative 2x, and then there was that 6. And then when we divide everything by 3, we get negative 2/3 x plus 2. So that number in front of x is a negative 2/3. So that is decreasing. The slope is going down. That's going to be our negative slope. Okay. The next one says when we're looking at quadratics. So when we're looking at quadratics, we see this exponent of an x squared. So notice all of these quadratics have an x squared. So that's important to be able to differentiate between linear and quadratic. And again, we want to have y equals, because notice for these first two, it's y equals and y equals. So we are like, okay, we can figure out what if it's concave up or concave down. So I'm just going to erase what I have over here so we can look at it. Because if it's concave up, that number in front of x squared is going to be positive. So here we see a positive 2 and a positive 1x squared. So both of these are going to be concave up, the first two. The next one we have is x squared plus 4y equals 7. So we would want to subtract x squared on both sides. And we end up with 4y equals a negative x squared plus 7. And then when we divide it by 4, we would get y equals negative 1/4 x squared plus 7 divided by 4. So once this is isolated and y is all by itself, that number in front of x squared is negative. So that's going to be a decay, or sorry, opening down. So just like with the linear function, we're looking right in front of the x. If it's positive, it's increasing or opening up if it's quadratic. If it's negative, it's decreasing if it's linear, or opening down if it's quadratic. And then finally, with exponential functions, we look and we notice that the x is the exponent. So the x is in the exponent for each of these. That makes it an exponential function. So to figure out if it's growth or decay, we look at the number that that x is being raised to. So for the first one, it's a 3. 3 to the x. 3 is bigger than 1. So that is growth. The one underneath that is a 5 to the 2x. 5 is bigger than 1, so that is growth. And then finally we have a 0.5. 0.5 is less than 1. So when the base is less than 1, that is actually decay. So for that one, it's going to be decay for the last one. Okay. Once you have all of these sorted, push ahead to slide 5, and we'll take a look at the next one. Classify each function as linear, quadratic, or exponential. So maybe you want to try this one out on your own and see how it feels. And when you're ready, we can look at it together. Just giving you a second to try it. Linear means we have an x with just an exponent of 1, like here. This is a negative 2x plus 3. So this is going to be decreasing, but it is linear, right? It's decreasing because there's that negative 2 in the front, but it's linear. The other linear function we have is here, because again, this is an x to the first power. That's what we're looking for. Those are our linear functions. Quadratic has an exponent of 2. So we look and we find those exponents of 2. Here's one of them. This is going to be concave down, right? Because there's that negative x squared. Okay. And the second one where we see that exponent of 2 is here. So that's our second quadratic function. That will be concave up. It's a positive number in the front. And then finally we have two exponentials. One of them is growth and one of them is decay. This one is going to be growth, right? Because it's the number 2. 2 is bigger than 1, so that's going to be exponential growth. And the decay is going to be 1/2 to the x, since that is less than 1. Okay. Beautiful. When you're all set, push ahead to 6. Classifying from tables is next. So we can notice that when we're trying to classify whether it's concave up or concave down, or increasing, decreasing, growth, or decay, we can look at a table. So for this first linear one, our x values are just going up by 1 each time. -1, 0, 1, 2. That's going up by 1. And our y values are going up by 2. -1 plus 2 is 1. 1 plus 2 is 3. 3 plus 2 is 5. This is an increasing function. The y values are getting bigger as the x's get bigger. Let's look at quadratic. With quadratic functions, because they make like a U, we see sometimes the values get low and then they get high, or they get high and then they get low. We have this turning point that happens. Here's the turning point, because you can see at first we're subtracting 1, and then all of a sudden we're adding 1, and then we're adding 3, and then we're adding 5, and there's this difference of 2 each time. This is a quadratic function. We're going down and then we're going up, right? So this is an example of concave up. And for the next one, we're looking at an exponential, and we have 1 to 2. We can see that that's going up by 1, and then we're going up by 2. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 8 is 16. We're actually going up, multiplying by 2 each time. With exponentials, we're going to see these multipliers, and this is an example of growth. We see those values are getting bigger. I'm going to pause it right here for part 1 of the video, so go ahead and click the link when you're ready and get started on part 2, and we'll start on slide 7. Nice job, y'all.